Okay, so in this video we're going to figure out how to find the force on a charge in an electric field. So let us say that at some point in space the electric field has some magnitude E and some direction as shown in the picture. Okay, now if at this point in space we were to place a charge say positive Q, okay, then we ask the question, what is the magnitude of the force and what is the direction of the force? Now we can obtain all this result, okay, from simply the definition of the electric field itself, which is F over Q. So the force on the charge, the magnitude of the force on the charge, is simply equal to the product of Q times E. Okay, so this is how we find the magnitude. Now the question is, what is the direction of the force? The answer is very simple. If it's a plus charge, the direction of the force is the same as the direction of the electric field. On the other hand, if I have the electric field once again here, but if I were to have a negative charge, then the direction of the force on the negative charge is opposite the electric field. Okay, so the force in one case is the same direction as the electric field, but if it's a negative charge, it is opposite the direction of the electric field. So once you know this, we can do a lot of stuff. So let us look at a simple situation. Okay, here's what you have. You have a let's say you've been given uniform electric field in some space. Okay, and what you've been told is that a charge, a positive charge, Q, and of mass m, is moving to the right in this electric field, okay, with some speed, say v0. And the question is, if this, let's say that the electric field is only confined to some length, some height, say h. Okay, we're going to ignore the effects of gravity, and we're going to ask, how does this object travel in this electric field? So first question, how does this object travel in the field? So essentially what we're doing is we're asking, what is the path of the object? Okay, so the answer is going to depend on the force. So let's figure out the force first. Okay, so if, let's say, at some instant of time, the charge is somewhere here inside the field. Okay, at this point, we know what the force is on the charge. Let's do one thing. Just instead of the charge being positive, let's just say that the charge is negative. It'll just make my picture stand out a little better. Okay, so now what we have is I have a negative charge, and we ask the question, in what direction is the force going to be on this negative charge? And clearly it's a negative charge, so it is going to be it's going to experience a force in the direction opposite the field. Okay, so the magnitude of the force is going to be equal to QE, and it is going to be pointing straight down according to this picture, or the negative y-axis according to this picture. Now, as a result of this, okay, we can also ask, what is the acceleration? The acceleration of this charge is going to be equal to Q times E over m, which is simply F over m. Okay, here we use Newton's second law. If you look at this expression, since the electric field E is uniform, okay, QE over m is a constant. And if you recall from the two-dimensional motion that you've studied with a constant acceleration, now you realize that in this case, since the acceleration is pointing straight down, the path of this object is going to be parabolic. It's going to move along some kind of parabolic path. We already know. Okay, so now that we know that the path is going to be parabolic, okay, so it's going to be a 2D parabolic path. Now since the path is parabolic, okay, we can ask the question, like, how far is it going to land, how far is it going to travel, and all kinds of things. Okay, so let us say that let's just say that this initial height, instead of the total height being h, let's just call the initial height h for this particle, and we can use that to figure out everything in the problem. Okay, so we can find out how far it travels horizontally. So how far does it travel horizontally? And to answer this question, we'll make our chart. We'll make our X chart and also our Y chart. Okay, now according to this chart, delta Y is minus H, VIY is 0, VIX is V0, and A is negative QE over M because it's pointing down. So we can first use the equation for the Y chart, which is delta Y equals VIY delta T plus 1/2 AY delta T square, and we can obtain 0 times delta T minus QE or 1/2 QE over M times delta T square. This gives us the time as 2mH over QE. Once we know the time, we can also figure out the X distance by using simply VIX times delta T, which is equal to VO times 2mH over QE. So you see, a problem like this, if a charge is moving in a uniform electric field, we know that its motion is going to be one with a constant acceleration. So if it's moving at any angle to the field, it will end up being a parabolic path, traveling along a parabolic path. If it is moving parallel with the field, it will end up moving in a one-dimensional path.